This is a demo for Computer Science 414 term project. In this project, I trained a CNN and LSTM model to predict um, a caption based on an image. So, for example, the image is like for example, image is like this, and the caption will be um, like a bunch of food, vegetables on the table. Okay, so I have a cloud computing instance on the Google Cloud platform, and yeah, and then I upload the code and all the data to the cloud platform, and then train the model there using the Tesla GPU here to basically speed up the whole process by pretty much like 20 times. So here we go. Okay, so this is the notebook um, on the cloud instance. So like basically a whole bunch of imports and like torch vision, like um, NLTK, NumPy, like basically all the necessary like um, SK image for like image pre-processing. This is all the import for necessary model training. So yeah, let's import it, and then run all these, and then th- this part is to basically load the data into the load the all the image data here. Like the, the cloud instance has the same um, data as this. Basically, like 20 gigabytes of image data from Microsoft Cocoa datasets. Like this is for the training set, this is for the validation set, and it's basically loading the all the captions for the image into the memory. So it's gonna take a while since there are like 400,000 images in the dataset. It'll take a while to load. So what this does is to sample a random batch of images. I specify the batch size to be 64 here, so every time I call get item or get image, it will just give me 24 images out of 64 images to train on. Okay, so you can see here the data loader PY. So basically the image folder, the image folder location on the cloud instance is this. I'm showing you the local one on my personal laptop. Basically, it's loading the image and captions from the file here, from location here. Okay. So it's done loading, and then you change the device to GPU instead of CPU to speed up the whole process. So these are all the parameters to learn. Um, okay, and then we just initialize the CNN, and then the LSTM from the model PY file. Basically, just initialized all the necessary features like models, parameters, all of those stuff. So after that, let's run this. Yep, set the optimizer to be Atom and learning rate to be this, and then just train. You can see it's starting to train, like not really fast, but fast enough. I trained this model for like 10 hours, and using GPU for only 4 epochs, which is I think not fast, not very fast, but good enough for this project. And I saved after all the training here, saved the model to a PKL file using the torch save command to save the LSTM and the CNN to be. Oh yeah, so basically this project is using CNN to basically give me the feature of the image, and then use that feature vector as input to the LSTM model to generate words using the previous word and the CNN feature. That will basically give us the caption for the whole image. So basically, so load a batch, and then load the caption, like load the truth label caption, and then zero out the gradient. So every step just zero out the gradient, and then here we can see the feature is from the CNN. So get the features from the CNN to basically like a feature vector of size 300 and one row of 300 columns, and then we will predict the caption using the LSTM feature by inputting the captions and the features, and then we calculate the loss between the ground truth. The ground truth is here, and the predicted caption, and then we do back propagation here, and then we use the optimizer to step through the algorithm to basically tweak the weight and the bias of each individual neural cell or perceptron or whatever, and then just print out the stat here, and then we'll leave it to training. It will take quite a while, so we just skip here. Basically, we just output the model to this folder here. I've already trained the model. It's these. I already trained these, so I'll just skip the training here and then just go to the validation. Okay, so we in the validation part, we get the data loader, and in the mode test, which means it will give you a image and then and a caption for only on the test set. So it would, the model have never seen the data from test set before. So this way we can like validate the data and see how the model and see how the model works. And here we're just loading the package file here, and then specify the parameters basically, and then just load the weights and the bias and all those trained stuff here. So after it's loaded, wait, let me just run this. Okay, it's loaded, and then just grab an image and the image tensor from the data loader. Basically, it will give us the image and transform the image to a tensor using this rule here. Test, yeah. It will resize the image, crop it, and then transform to tensor, and then normalize it using the pre-standard normalization for the CNN net. And then afterwards, get the tensor and the image. It will just show the image here, like test image with this two babies dancing maybe, and then we will get the features from CNN. Oh, so the CNN here, and the CNN above is pre-trained, so it's a ResNet 50. It's downloaded from the internet, and it gives up a pretty good like feature extraction based on the image tensor. We can just unsqueeze the features, and then we'll get the predicted caption from the LSTM, and then we will just generate the prediction based on the index the LSTM gives. The LSTM gives us index to the word, so based on the index we can get the word from the vocabulary dictionary file. Like here, basically just one-to-one mappings, map the index to the words. So this is the string to save the index, and then just for each of the index, we'll just get the actual word from the vocab, and then just append the predicted caption word to the sentence, and then we'll show the image again, and then show the caption. Basically, here, so the caption is like a star token, and then the end token here, and then it will be like this is each of the predicted word based on the previous word and the spatial data from the image. And we can see here the model didn't perform as good as other images. It misplaced the little guy with like a teddy bear. Basically, that's not as good. But we can run again and see some of the good examples. So run again, load the image, load a different image. No, it's actually here. So this image is. Let's see how this one does. And then just this one just cleaning up the sentence here to become a like more like a sentence instead of just like tokens. So here, like a man in a field throwing baseball with a white socks. This one is not as good as well because of the cluttering of the nets here, but you can see the model recognized the baseball field and the baseball bat, and then but there's no baseball here, but it just recognized like people in the baseball field, like basically they would just like throw baseball. So it's not this one is not as accurate as well. We can try another one. Okay, this one should be pretty accurate because of the image is pretty clean and like it's pretty clear like what the image is. Then we'll just predict it again. Okay, it will be a man with tie and a microphone. So this model think this one is a microphone, and then because of the short hair thinks this is a man. This image is not like this model is not perfect, but it definitely knows something. So this is another bunch of orange heading from tree. Well, it's clearly peach, but mostly correct. Mostly correct. Let's try again. Load a different image, then predict the caption, and then clean up the sentence. I mean, I'm wearing a tie and a shirt. It's pretty obvious, but it's not as good. Let's try again. So, a bird perched on a windowsill. I don't know what that means. Okay. Do again. Display of various fruits and vegetables on a table. Well, there are some vegetables, fruits, but there's no table here. So as we can see, the model is not perfect because only trained for like 10 hours, only for 4 epoch. To improve the model, I would definitely like increase the training time to get more resource, more GPU power, all those cool stuff, and train again to get a better result. But I think the result is like good enough at this stage. It's only taking 10 hours of training. So cat is drinking water from toilet. Well, it's a toilet, but it's not drinking. But it's basically the model gets the idea of the general idea of the image, but needs more refined details to for outputting the captions. This is pretty correct. A pretty accurate living room couch and table. Pretty standard. I think it does well on the standard images. Let's try again. See more results. So good people standing around truck with metal pole. Standing around truck, yeah. There's a there's a bus. Oh, this one definitely not as good because of the sheep. Like normally you don't see sheep on the roads, right? Okay. Okay, a herd of zebra is walking across the field. This is pretty accurate, but the background is not zebra. Yeah, so pretty much this is the performance of the model.